Dinosaurs are dead, but not because of an asteroid. Okay, so for decades, most scientists have agreed that this event 66 million years ago was the one that killed off the dinosaurs, or more accurately, the non-avian dinosaurs. And it's supported by really good evidence because we've identified the crater. It's now largely buried on the seafloor off the coast of Mexico. It's exactly the same age as the extinction of the non-bird dinosaurs, which can be tracked in the rock record all around the world. But some scientists don't think an asteroid impact was to blame. They think something else caused this mass extinction. So who's right? Well, to answer that question, let's first talk about what we know happened 66 million years ago, and then look at both sides of the asteroid debate. Okay, so first things first, when we say dinosaurs died out 66 million years ago, we're talking about the extinction event at the end of the Cretaceous period, which is the last period of the Mesozoic era. This extinction event, which also wiped out about 75% of all species on Earth, is often referred to as the Cretaceous-Paleogene, or KPG, event. The asteroid impact hypothesis has been the prevailing explanation for this event since 1980, when a pair of geologists proposed it. And there are three main pieces of evidence that point to an asteroid. The first piece of evidence is the KPG band. This is a thin layer of rock that's found all over the world, and it contains a high concentration of the element iridium. Iridium is rare on land, but fairly common in space. And the amount of this band around the world suggests that whatever caused the mass extinction was global in scope. If it had been something localized, like a volcano, you wouldn't expect to see the same layer of sediment in places that weren't affected. The second piece of evidence is that the boundary between the Cretaceous and Paleogene periods marks a sudden change in the fossil record. On one side of the boundary, you have fossils of dinosaurs and other Cretaceous animals. And on the other side, you have fossils of early mammals and other Paleogene animals. And if you examine sediments laid down just before and after the mass extinction, you'll see that the transition is really abrupt. In some places, the oldest Paleogene rocks contain spores from plants that appeared only after the mass extinction. And in other places, the youngest Cretaceous rocks contain fossils of animals that disappeared in the mass extinction. These patterns suggest that whatever caused the mass extinction was a global catastrophe that wiped out a lot of life very quickly. And the third piece of evidence is the crater itself, which was discovered in 1978 off the coast of Mexico. Today, it's called the Chicxulub crater, and its location and age make it the top candidate for being the impact crater from the asteroid that killed the dinosaurs. It's located near the Yucatan Peninsula, and it's about 180 kilometers or 110 miles across. Scientists estimate that the asteroid that formed the crater was about 10 to 14 kilometers or 6 to 9 miles wide, and that it hit Earth at about 43 kilometers per second, or 27 miles per second. An impact that big would have blown a lot of dust and gas into the atmosphere. And depending on how much, it could have either warmed the planet or blocked enough sunlight to cause an ice age. Either of those would be bad news for dinosaurs. Now, normally, evidence like this would be enough to settle an argument, but not in this case. There are people who argue against an asteroid impact, and they point to three main problems with the asteroid hypothesis. The first problem is that they can't agree on the cause of the mass extinction. Asteroids are known to cause mass extinctions. For example, 252 million years ago, a series of volcanic eruptions released massive amounts of lava in what is now Siberia. We know that these eruptions released at least 3 million cubic kilometers of lava, which is 10 times more than all of the lava produced by Mount St. Helens. And soon after these eruptions took place, 90% of marine species went extinct. This event, called the Great Dying, was the worst mass extinction in history. And although scientists aren't sure if an asteroid impact played a role in it, it's definitely linked to a series of asteroid impacts that happened at roughly the same time. But scientists disagree on whether the same thing happened 66 million years ago. One group of researchers says that the asteroid impact was the cause of the mass extinction, while the other group says that the asteroid didn't do anything on its own and that volcanic activity was actually the main cause of the mass extinction. So if you ask one scientist why dinosaurs died out, they'll probably say it was the asteroid. Ask another scientist the same question and they'll probably say it was the volcanoes. The second problem is that they can't agree on the effect of an asteroid. Some scientists have argued that the asteroid impact was too small to have caused such a large mass extinction. To support this idea, they cite computer models that show that an asteroid that size would not have caused enough climate disruption to kill off the dinosaurs. On the other hand, other scientists argue that the asteroid impact alone was big enough to cause the mass extinction, citing computer models that show the opposite. Even worse, other researchers say that the impact may have been big enough to cause the mass extinction in some parts of the world, but not others, which contradicts observations showing that the mass extinction was global in scope. The third problem is that they can't agree on the age of the crater. A few studies have suggested that the crater is actually older than the mass extinction, which would mean that something else caused the mass extinction, or that the asteroid impact was too small to have caused it. However, most scientists think that this is just a misunderstanding. According to them, the crater is actually the right age. So who's right? Well, I asked some scientists that question, and this was their response. Okay, so as a group, the asteroid camp agrees that asteroids can cause mass extinctions, and that this particular asteroid was big enough to cause the mass extinction, at least in part. They also agree that the crater is the right age. As for the volcanoes, they acknowledge that there was a lot of volcanic activity during the late Cretaceous, but they say that it wasn't significant enough to have caused the mass extinction on its own. Plus, the oldest rocks from the mass extinction still predate the crater by several thousand years. So they conclude that the asteroid impact was the cause of the mass extinction. In contrast, the anti-asteroid camp agrees that the asteroid impact alone wouldn't have caused the mass extinction, but they disagree that the crater is the right age. They think that the crater formed during the latest Jurassic period and that something else caused the mass extinction. They haven't been able to come up with any new ideas yet, though, because they haven't been able to study the asteroid crater itself. You see, the reason why there's so much disagreement is that we can't get to the asteroid crater to study it. It's under about 1 kilometer or 0.6 miles of sediment on the seafloor, and drilling that deep into the seafloor isn't easy. Now, researchers have considered this problem and they're actually working on it. The International Ocean Discovery Program has planned an expedition to drill into the crater, but they won't be able to start until 2024. So for now, the anti-asteroid folks don't have any new ideas, but they do have one major piece of evidence. In 2016, 2 researchers re-examined sediments from the KT boundary in North and South America, Europe, and New Zealand. And in every location, they found that the mass extinction happened a little bit before the iridium spike. Now, this doesn't prove that the asteroid didn't cause the mass extinction. The asteroid could have fragmented and the different pieces hit Earth at slightly different times. But it does complicate the asteroid hypothesis. And according to some scientists, it throws the asteroid hypothesis into complete chaos. So I guess we'll have to wait and see what the results of the drilling expedition are. Maybe they'll find evidence that the crater is younger than the mass extinction, in which case the anti-asteroid folks will be vindicated. Or maybe they'll find evidence that the crater is older than the mass extinction, in which case the asteroid folks will be vindicated. Or maybe they'll find evidence that the crater is the right age, in which case the asteroid folks will be doubly vindicated. Speaking of vindication, I'm going to go back to the drawing board to figure out how to explain relativity. See you next time.